more examples. So we have, in the last lecture, we have looked at arrays, how to write arrays in Solidity. And then we have also looked at how to write structures also. So today we'll look at what are enumerations and how to use them. So I'll take this code. I have written some basic codes for helping you all understand the concepts. Let me just take this example to ID. Created a new file. I need to be aligned with the Solidity version which is available or with which I am compiling. That's a major thing that you should start with when you are writing your codes on Linux. Okay, so in today's lecture, we are going to look at more coding examples. So this example is of Solidity, enumerations. So how do we write an enumeration and what is an enumeration? So when I want to declare certain constants in my code and I want to list them together. So in that case, I can make use of enumerations. So this is a simple code example in which I'm trying to present the shipping or the order delivery status. So let's understand the syntaxes. So this is my contract enum. How to write an enumeration? You have to use the keyword enum. You have to give a name to the enumeration. So I have given the name of the enumeration as status. And in the curly braces, I can decide on what all status I want to give for a particular order. So I have just listed some basic status like pending, shipped, accepted, rejected, or cancelled. So the default value of an enumeration is the first element listed in the enumeration. So in this type, which we have defined, is pending. So the default value is always the first value which you list in the enumeration. Next, what I did is I have created a variable of enumeration. So you'll observe that enumerations are very much like structures. So how to declare a variable of type enumeration? So status is the name of my enumeration. Then I've given the access specifier as public. Next, I give a variable name. So in order to ease the use, I'm keeping the same variable name, just using a lowercase variable, that is status. So I've created a variable of enumeration type. Okay. So by default, the enumerations are listed by integer numbers by default starting from 0. So these enumeration returns unsigned integer type. That is also important to remember. So it is not going to return string, it is going to return uint. So how is this unsigned values assigned? So starting from the list, the first element in the enumeration would be given 0, 1, 2, 3, and so on. So this is just for understanding purposes. I have written everything in comments so that when I give you the code, you can easily understand and run it. Next, I'm writing a function get. Okay. So get function basically we write for just printing what is the value of that variable. So in the returns, I have written status, which means that the return type is of status type, which means it's an enumeration. I'm returning an enumeration. So return status. Okay. So this small s status is basically the variable which is created of type enumeration. Next, what can we do? Next is once you just print what are the different status, next what we can do, we can change the status also. which is updating the status by passing some uint value into the input field. So how can we do that? Let's see an example. So this is my function set, okay, to which I am passing an argument of type status and through which I am assigning the status. Okay, so this is underscore status I have taken, which is the user input given to this function set, and that value I am passing to the enumeration variable. So we can also update the enumeration variable to one specific type if you want to do it manually. For example, I have written a function cancel for canceling the order. In that case, what I can do, I have written a function cancel and I'm directly updating the status as status dot cancelled. So automatically the cancelled value would be stored in status. The last function that I'm writing is a reset function. If I want to reset all the values that I have set in the code, I can use or write a function reset, and simply using the delete keyword or delete method, I can directly delete all the status which has been set around during the smart contract. So this is just a simple demonstration of writing an enumeration in Solidity. So I have compiled this. Let's deploy it. So I'll select an address and then let's deploy. So this is my enumeration smart contract. So if I just say get status, okay, what was get status doing here? It was returning status. Basically, it is 0, which means it is set on the default value. Okay. Now let us try calling the set function. So to the set function, I need to give or pass an integer value. So we know that all these enumeration types are numbered from 0. So if I set the status to 2, okay, if I get the status, yes, it's working fine. The status is getting changed. Next, if I want to cancel, let's go and understand what is the cancel function. So cancel basically directly sets the status to cancelled. Okay, so let me just cancel this and say get status. Okay, so it has automatically, if you see the get function, it is representing 4. What is 4? 4 is the uint value for cancelled. So yes, my cancel is also working fine. If I click on status, it is giving me the current status, which is set to cancelled. If I do a reset, what is the reset function that we have written? We are deleting the status. So if I do a reset and say get, okay, automatically the value sets to the first value in the enumeration, that is 0 by default. Okay. So this was your enumeration example. I hope everyone has understood this, right? So in this way, we are going to do practice codes for each and every concept that we have studied for Solidity programming. So this was enumeration. We have already taken arrays, structures, and then enumeration. So enumeration is a way of declaring constants, but under one name or in a form of a group. So if you look at this enumeration, pending, shipped, accepted, rejected, cancelled, all these are constant values, but they all are listed under status. So let's try some other code. So this was enumeration. We can write for loop, if else conditions in order to write our coding logic. So let's explore that as well. So here I've written a very basic example for demonstrating loops. That is just write a new smart contract or loop. So all the basic conditional checking statements, checking for some conditions in code like if else if ladder, All the things like you have studied in the previous programming language are directly applicable, only a little change in the syntax. So let's understand the second example in which I'm just demonstrating how to write loops in Solidity. So this is my contract sum of natural numbers, and I'm writing a function calculate sum, to which I'm passing just n, which is the user input, like how many numbers you want to calculate the sum for, and I'm just returning the sum. So inside this calculate sum function, I have declared a variable sum is equals to 0. And then using the for loop, you will just observe that the for loop syntax is exactly same as C++. So for I've taken a uint variable I, and it starts from 1 to less than n I plus plus, and I'm just adding on the values and returning the sum. So the for loops are exactly the same as we do in C++. So let's deploy this also. So all these are basic building blocks, which once you learn it, you can start writing some use cases. So I'm just entered the value of n here, which is 3, and it is just calculating the sum of all natural numbers. That is 1 plus 2 plus 3. Now, one thing to observe here, we have studied different types of variables that we can declare in our Solidity code. There are state variables and there are local variables, okay? So here, if you observe, I have not declared any state variable because there is no variable which is present inside the contract. Whatever variables are declared is inside the function. So all these variable n, sum, I, all these are local variables. The variables that you declare inside the contract are called as state variables. Okay, so this is a very simple example just to demonstrate how to write for loops in Solidity. Next, we move on to using if-else statements. So once we are done with this, in the tomorrow's lecture, we have to actually perform some um, real problem statements using all these concepts that we are studying. So let's write a simple code for if-else. So always keep an eye on the Solidity version compiler that you're using and the one that is set in code. Otherwise, it gives an error to you. Okay, so in order to demonstrate how to write if else if, it is the same as you write it in any other programming language. So let's understand this code. So in this contract, I have written a function foo, which takes just one input from the user, which is x. And I'm just checking certain conditions like if x is less than 10, return 0. Else if x is less than 20, return 1. Else return 2. So this is just a very common example of if else if ladder. So you may use if else or you may use if else if ladder for checking nested conditions. Then there's also a ternary operator, which can be used for checking conditions. So in order to demonstrate that, I have written one more function, which is ternary, the same, a single variable input I'm giving to this function. So how does this help? Like how does using a ternary operator help rather than using if else if ladder? So I've just commented the code, if you can see. If x is less than 10, return 1, else return 2. So the shorthand way of writing if else statement is using the question mark colon, which is the ternary operator. Okay, so this could be written only when there are two possibilities. If there are more than two possibilities, you may not be able to use the ternary operator. So that is one limitation for that. So what am I doing? I've just commented this code because instead of these 3 lines of code, I can just wrap up the entire thing in a single line. So remember that when we are deploying smart contracts, we are paying gas fees to the network for executing the functions. So gas optimization is one major concern. So as many lines of code you reduce and as many less complex logic you write is the gas optimization that would help for. So let's understand this. The syntax for using the ternary operator is very simple. You have to just write the variable name, which is in this case underscore x, and the operator is less than. So if x is less than 10, it will return 1. If it is false, it will return 2. So the operator is question mark, and then you can just put in the values you want to return. If true, the first value would be returned. If it is false, the second value would be returned. Okay, so this is just a very simple demonstration of how to use if else if ladder. Also, if you are just looking for two values, like if the return types are just two, either true or false, you can use the ternary operator instead of if else, as it saves the lines of code written, right? So up to this point, we have looked at writing enumerations, next writing for loops, and then using if else if or a ternary operator. Okay. If at any point you have a doubt, you may put your query in the chat box, or you may just unmute and ask. So next we will look into the types of variables. This is also very important because in order to write our logic, we need different types of variables in codes. So let me just create one more contract. Okay. So let me change the Solidity version here and compile this. Right. So with this, I would be demonstrating the different types of variables that we can use in Solidity and what are the different access specifiers, the scope when you write the variables. So let's look at this simple code. So this is my contract variables. In this, immediately after the contract, you have written two variables, which is text and num. So these are called as state variables. I have commented every statement so that you understand it better. So these two, which you have written directly inside a contract, are called as state variables. What is the significance of a state variable? The state variables are stored on the blockchain, which means that these are stored permanently. So this text and num, which I have directly initialized here, text to hello and num to some number. So this are called as state variables because I have declared these variables inside the contract and they are stored permanently on the blockchain. Let's explore other variables. So here I've written function do something which returns two values. One is unsigned integer and the second value is an address. Okay. So in this, I have declared a variable I of unsigned 256 type and assigned certain value. So this variable I is the local variable and these are not stored on the blockchain. The value of local variables exist only during this function. Once the function call ends, the value of I would not be retained. Okay. So this is the example of a local variable. Any variable that you write inside a function is a local variable. So it consumes less gas and less space as compared to state variables. Next, very important that we need to understand is what are global variables. Okay. So a global variable is a variable which is directly fetched from the blockchain state. There are many such variables, like one you see here is an example of block.timestamp. Okay. So this statement block.timestamp returns the current block timestamp. What is block.timestamp? For this specific block, what was the timestamp? The time when it was added to the blockchain. So this block.timestamp is calculated by the blockchain network itself. It is not a user given value or a state value. It is the blockchain's variable. So there are many such variables which we can directly use to fetch the value from the blockchain network. The examples are block.timestamp, block.number, block.nonce. So there are many variables. So if you're trying to access a global variable, means you are directly fetching a variable whose value is maintained, updated by the network itself. So if I declare a variable timestamp is a user-defined variable that I have given of unsigned integer type. To this timestamp variable, I am assigning the value of block.timestamp. So whatever is the current block timestamp on the blockchain would be stored in the variable timestamp. And then I'm performing certain operation on the variable num, that is num plus timestamp. Okay. So num is something which I have set as a state variable there, 123. So this will automatically fetch the current block's timestamp and add it, perform a mathematical calculation with number. Next, I'm using an address as a data type. Okay. So address is basically a special data type in Solidity which can hold a 20 byte of Ethereum address. Okay. So what am I doing? Address, the variable name is sender, is equals to message.sender. Now message.sender is also a predefined method in Solidity which is used for fetching the current address which is, or the current account which is used while you are accessing this smart contract. Okay. So message.sender is a predefined method. You are not writing it. It's a predefined method present in Solidity which fetches the account which is used for deploying the contract or current account which is selected. So that value would be passed in the variable sender, and this function is returning two values as you see here. One is unsigned integer and the second is address. So I'm returning here num comma sender. Okay. So with this code example, we have looked at three different types of variables that you can use in Solidity. The first is state variable, the variables that you declare inside a contract which are stored onto the blockchain. The second is a local variable which you declare inside a function and the values are not saved to the blockchain. Third is a global variable which you directly use from the blockchain network. The examples are block.timestamp, block.number, block.nonce, and many more. So let's run this code. Right, let me just close the previous file and deploy this. Okay, so this is my execution window or the way I can interact with the smart contract. So you observe that whichever variable you declare as a public and state variable are visible while I'm interacting with the contract. Also, all the functions that you write, because functions by default, you write them as public so that anyone can access the functions. So that also gets visible for interaction in the deployed contracts tab. So if I click on number, it will display the default number that I have set. Also, if I look at text, that is hello. So if I call this do something function, okay, so what is this giving? Let me just check. Okay, so here I can see in the logs, I have not basically printed them there properly. That's why it's not visible here. But yes, I can look
Hello.
at the value. Yes, please. Anyone who wants to say something or ask? Okay. So let us go back to this code. So here, if you just look at the logs, okay. So this is the compiling or the debugging window that you can look at. So this is my final transaction in which I'm just calling variables dot do something. You can see the status: one transaction mined and execution succeed. This is the transaction hash. This is the block hash. This again block number which you see is the blockchain's global variables, which you can access from block.number, which is right now the block number is 14, from which address it was called, and do something. So that is the contract itself gets an address when it is once it is deployed. What was the transaction cost, execution cost, the output. Okay. So what do you see as the output here is this. Okay. So this do something function was returning two values. That was, one was unsigned integer and the second one was address. So what is happening? Unsigned integer, you see some very long number, right? So why is this number so long? Because what I have done is I have done a calculation of num plus block dot timestamp. So what, how does block dot timestamp look like? It looks like a very long number. So that is the time from a particular year, some 1971 till date in seconds. So it's a very long number, and I've added that to num, which is 123. So in this way, you get this value. The second one is the address field, which you can directly go and check here. So the address field I have set to message.sender. And what is message.sender? It directly fetches the account address that was in use when that function got called. So this was the account which was in use, that is 0x617. You can match that value 0x617. So it fetches, and you can also match the last digits because the rest is not visible here. 5e7 5e7f2. So it directly fetches the account address which is currently in use. Okay. So this is how you interpret the output here.